This is the moment that if it goes and tries to put that tool up in that ATC and it can't fit, we can end up crashing. What's up guys? So in our last video, we started the machining process on our custom snare drum for Dan Palovich. Now in that video, we mounted it to our custom fixture that we made, we roughed the outside, and we finished the ID. Now it's time that we flip it over and we get rid of this hat off the bottom as well as finish the OD of the drum. And after that, this thing is complete. So in order to do that, we're gonna have to hold on this ID. Now, we can't use this fixture for that operation. So what we're gonna do is we're gonna throw this chuck in the machine. Now this chuck may look familiar to you. This is the one that we used on our Boombastic part that we did back in May. But there is one problem with this. See these jaws? These are standard jaws, and I can tell you that when we clamp on our part, it's gonna cause the drum to distort. So what we need is some pie jaws. Looking online, I didn't really like any of the ones that I found, and typically they're sold in sets of 3, and this is a 4-jaw chuck. So I just decided to make my own. So in this video, I'm gonna show you guys how we can make our own custom pie jaws. First, let's take a look at the design. Now there's a couple things we need to consider when we're doing this last operation on the drum, and both of them stem from it having thin walls. Now the first is chatter, so we need to make sure that the part is dampened well, and the other is distortion. So because of the large diameter and the thin wall, it's going to be pretty easy to distort this part. So this is where pie jaws comes in, and it basically solves both of those problems all in one. Typically when you purchase pie jaws, they give you the full slice of pie, right? That goes all the way down to the center. But we really don't need that. We're going to be boring these to hold on the ID of the drum, which is a pretty large diameter. So we can save ourselves a little bit of material by not having to go all the way to the center. And typically when you find these online, the thickest that you can find is right around 4 inches thick. But our drum is a lot thicker than that, and I want to make sure that I dampen this part all the way up. So I need something that's about 8 inches tall. I've designed these jaws to be able to be used with a 4-inch thick piece of material, 8 inches wide, and sawed to length. So by doing that, I can use a standard bar stock. So if I look directly on top of this jaw, this height here, that's our 4-inch thickness, and that's really all I need there. I just need enough to be able to hold steady and be dampened. Now the length right here, that's our 9.5-inch length, and we're using that 8-inch width of this bar stock to be the height of the jaws. Now if I turn on my drum here, you can see that I don't quite get all the way out to the end, and I think that's going to be okay. I really wanted it to be encompassing the entire ID, but I also need to make sure that this drum is up off the chuck itself. You know, we want a little bit of clearance there. We can see I've got a shoulder down here on the bottom of the jaws that we're going to turn to, and our drum can just sit down on that shoulder. And then I've recessed the top back a little bit further, that way we can take our tool and finish this entire OD. But we also need to keep in mind that we have that vent hole. So what I'm going to do there is I'm just going to come in and make a little pocket on this one jaw. That way we have some clearance in there for that boss that sticks up for the vent hole. But other than that, we can make this out of straight up bar stock. So for the first operation, we're going to do this bottom side here, and we're just going to cut this clearance back on these two faces. Now this is the side that's going to get turned for our radius for the ID of the part. So I know all of this material is going to leave anyway, so I'm just going to use it to put a dovetail on it for when I flip it over and machine the other side. And after that, we can hold on that dovetail. Now on this side, we're just machining with a face mill our clearance, so that way our jaws can get closer together. We're going to do our counterbore holes for the bolts, and we're going to machine the teeth in it with a flat end mill. Now typically with smaller chucks, this is a 60-degree tooth pattern, but for the chuck that we have, it's a 3/32 by 90-degree serration. So since it's a 90-degree, I can just flip this up on 45-degree angle and machine it with a flat end mill. So these two operations are going to be pretty quick, and for that I'm going to use the DVF 5000, and after that we can mount it to our chuck in our 8000 so we can finish it out by turning the OD and mounting our drum. All right, so we're going to go ahead and start Op 2. And I just wrote a quick little probing cycle and I entered it into my program as a subroutine. Come in here and touch off all my work offsets. But I get asked a lot, how do I do a manual tool change? For instance, if I had a tool outside the ATC of the machine. And I thought this is a really cool time to show you guys a neat feature here on the Cinemeric control, because I'm doing just that. So if you've got a large tool, let's say like a right angle head for instance, or something that's too long to actually be able to go in the ATC of the machine, and you have to leave that tool outside of the machine, finding a foolproof way to do that on some controls can be kind of difficult. In the past, I've put like a tool holder that doesn't have a tool in it and put an M0 in the program with a comment to the operator to say, hey, change the tool out to this tool. And after it runs, I have another M0. And the problem with that is I'm really relying on that operator to pay attention and change that tool out when he's supposed to. If not, we can have a big problem. Now, the Cinemeric control has a really cool feature on this to where it really dummy proofs it for you. All right, so you can see my face mill is running after my probing cycle. And if I look right here, I can see that my program stop, my M1 is not checked. So it's just going to run through this program. And that's kind of important because I want you to see how this machine acts when it comes up to this drill that I got to put in the machine. Now I got a KSEM 32 millimeter flat bottom drill. That's the FEG insert from Kennametal. We're going to use that drill for the counterbores on these jaws. With it put in that holder, it's a 5x D drill. It's way too long to be able to put in the ATC. So I'm leaving it outside the machine. And I want you to see how this machine handles changing this manual tool change. All right, so we can see right now that it's going ahead and changing that tool out. So what it did is it just put that tool up. And if I look at my screen here, it says manual tool load command 1, open operator door. So it's telling me step 1, open the door. Now, it knows to do this because on my tool data page, so here's all my tools that I created that's inside my machine right now. I can see the location. These are all the pot locations in the ATC. So if I scroll down here, I can see that I have 60 tool locations, but now I see some tools below here that aren't assigned to any number. So that what that's saying is I've created tools that are not currently in the machine. And if I look at the bottom of this list right here, there's my 32 millimeter drill. So all you have to do is create the tool and don't put it into the ATC, don't put it into a location. So once the program sees that it's trying to call up a tool that is not assigned to this location, it knows that you're doing a manual tool change. So if I go to my message screen, it's telling me to open the door. Now here's the really cool part about this, because if I hit cycle start right now, it will not let me run this program. It knows that I have not opened that door, and it's kind of a foolproof way to make me open this door and change this tool. But it actually goes another step further. So watch this. So it's telling me to open the door. Once I open that door, the message has changed. It's telling me that the door is open, but now it's telling me step 1, unclamp the spindle, step 2, clamp the spindle. So it's smart enough to know it has to unclamp and clamp that spindle for me to put that tool in. So it's not just going to let me open the door, close it, and hit cycle start. And that is the cool part about this feature. So now the spindle's open, I can grab my tool and put it in the spindle. Make sure it's clean. Put it in and clamp it. Now notice it's changed my message to close operator door. So it's walking me through the process as I go through this. And it's not going to let me run unless I follow its exact instructions. So all right, we're going to close the door. last step is it's going to tell me to hit cycle start, and that's going to continue my program. So if I come back here, we hit cycle start. Now it's going in and drilling the hole. Now again, I do not have M1 selected, so once this drill is done, it's going to change out to the next tool. And here's the second part that is kind of scary when you're on a different control and you don't have this type of logic written into your control, because if we don't put that tool in the beginning, no harm, no foul. Like, we're just missing a feature in our part. Yeah, we may scrap a part if we take it out and don't realize that, but we don't crash anything. Now, this is the moment that if it goes and tries to put that tool up in that ATC and it can't fit, we can end up crashing. Now notice on my screen, it's calling up the next tool, which is the 866 drill that drills the through holes. But it knows that it's got a manual tool change, so it's went over to the ATC position and it's stopped. Now it's going to tell me basically to run that process again. It's going to tell me to open the operator door, unclamp, clamp the spindle, and walk me through that process just like it did before. And I'm going to have to really, not want to do my job correctly for me to mess this up. So this is a real foolproof way of doing this manual tool change. All right, so I've taken the tool out, nothing's in the spindle, and I can see it's telling me to close the operator door. Close the door, now it wants me to hit cycle start. So come back here and I hit cycle start, and it continues my program. So I wanted to show you guys that because I thought this was really cool and a really seamless way of handling a manual tool change. All right, so Op 2 is done on all of these jaws, so that's all we're going to do on the 5000. Now we need to get the drum out of the 8000 and get the chuck mounted to the machine. So we got the drum out of the machine, we took out the second op fixture, and we mounted our Shunk Rota M-Flex 630 chuck. Now it's time to get our jaws mounted on the chuck so we can get this last operation of the turning done. Now I'm pretty excited to show you guys how I programmed this because I didn't use any CAM software for this operation. So we got our jaws mounted on the chuck, and I wanted to kind of show you some of the things that I had to think about when placing these jaws. You know, anytime you're doing pie jaws, you want to make sure that you're getting as much coverage as possible. So I don't want a huge gap right here in between these jaws. But I couldn't put them all the way up against each other because remember, we got that little boss on the inside of this drum that we have to overcome. So I don't want to put a pocket all the way up this jaw. So I want to leave enough space right here and enough travel in my jaw to be able to close it enough to get the drum on top of it because of that boss. And I also don't want to put these too far away because then I will turn this diameter into my counterbore holes. So I had to think about all these things and have enough movement to make sure that we clamp properly. So the last thing we're going to do here is we're going to take a piece of banding material and wrap it around the outside to hold pressure pushing outwards, the same as we will have on our drum. So we're going to do that now. To turn this, we're using a CNMG 431 polished insert, which is great for aluminum. And as you can see, I'm using a neutral holder, which means that we're going to have to turn this with the A-axis on a 45-degree angle. Now I did that mostly for clearance so we can get away from the chuck. I programmed this using ShopMill, which is the conversational programming on the Cinemeric control. This is our entire program right here. That's going to rough and finish turn. It's going to come in with a 1/4-inch end mill and mill out a pocket for that boss. And it's going to come in and chamfer that pocket. So all of that resides right here in this short program. Now, I love this because it's super easy to use. You know, even Barry could figure this out with some adult supervision.
Oh, yes!
If you have to do simple things, programming it at the machine is going to be a lot faster than programming it in CAM software, especially if you worked at places like I've worked where you have an offline programmer and a machinist at the floor. Every program that I wrote, there had to be a setup sheet to accompany it. Now that means I had to specify every single tool, holder, where the work offsets were, detailed instructions. All of that takes a lot of time, especially if you're doing something like squaring up a block. Every single shop mill or shop turn program starts with a program header. And inside there, you just are detailing what size stock you're using and basically your retracts for the entire program. Now, whether you're doing like an optimized retract or if you just want it to come all the way up to a certain plane, you do that right here in the header of the program. But you also have the ability to add G-codes. As you can see, I added this M560 right at the top, which puts my machine in turning mode. And I also added some M1s, so optional stops. So I can actually add logic in here, I can add probing, I can add any G-code positioning that I want. You can mix and match this, and I can even call this as a sub-program inside of my G-code program as well. So there's a lot of flexibility that these controls have with this conversational G-code program. Now for the turning on this, you can see right here, I just defined my contour, which is here. So I just go in and define each line segment, and then I come in and I tell what I want to do on that contour. So first thing, I've got stock removal, which is roughing it out. I open that up, and as you can see, I have my tool specified and what angle that I want to turn that on, feed speed, depth of cut, all that stuff right here. And then after that, I tell it residual cutting, which is my finish pass. Select the tool, same thing. What angle you want to cut on and how you want to cut. It's very simple to do. There's not a whole lot to actually answer in here and get a very good program. Now that does it for the turning. So after that, we're going to come in with a 1/4-inch end mill and mill a pocket on the top of one of the jaws. Well, I'm going to do that at 90 degrees. So I can set my swivel plane right here to tell it to rotate 90. Also in here, I've told it to shift my 0 up to the top of that jaw. So when it runs this end mill, the top of that jaw is actually going to be 0. So then after that, I can come in and just write a simple rectangular pocket. I just give it the dimensions, how deep, the width, the length. But something that's really cool is right here in ShopMill, you can program with surface footage and feed per tooth, which is what I did on this. I'm actually programming at 524 surface footage, which puts me at around 8,000 RPMs for this tool, and 1 thou feed per tooth. You know, I'm running without coolant here, so I'm not getting too crazy with it. But what's cool about this is whatever way you program it right here in the program, you see it on the machine page as it's running. So if I decided to go in here and change that tool for some reason, my feeds and speeds are going to follow it, as you would anytime you run surface footage and feed per tooth. But where it's getting that feed per tooth is on the tool data page. I can see this tool right here. I've told it that it has 3 flutes right here on the tool data page. So that's going to dictate the feed that I'm going to get from the program. So if I change that right now, it will change my feed rate. which is really cool. And then the last thing we're going to do is I just copied it down and I changed the tool in it to a 1/2-inch chamfer mill. And I changed my type of machining to chamfer. And I'm putting about a 15,000 chamfer on that. And after I do that, that program's done. So it's that simple to do. I just adjusted the chuck until I got very slight pressure on it. What I'm doing is I'm feeling for that little boss in there. I can feel both sides. And I'm kind of coming to what I think is the middle, just to make sure that I got enough movement on both sides. But before I tighten it, I'm actually going to flatten this out and let gravity help me out and seat this thing on the bottom. All right, so we got the drum all mounted up. This is going to be the final operation on this drum. We can get this to Dan. Hope you guys enjoyed this video. Hope you learned something. If you did, please give us a like. We'd really appreciate it. And go ahead and subscribe if you want to see more content like this. Next video you're going to see, we're going to finish this drum out. We'll see y'all in the next one.